Here it is, issue 315, the last one before the Easter holidays. So it'll be a few weeks before the next one's issued, because that'll be after the Easter holidays. And what's it got in this particular one for the puzzle? Here it is. This week's puzzle. X, Y and Z are angles in a triangle. So they are, standard triangle there. What's larger? Tan X plus tan Y plus tan Z, or the product of them, tan X times tan Y times tan Z. So here we are then. There's the triangle. So which is bigger? Is it the sum of the tangents, or is it the product of the tangents? Well, this is Chris being a bit naughty again, because in fact they're both the same. But how are you going to prove that though? In order to do that, you would need to know your tangent identities. And unfortunately, in Scotland, those are no longer taught. You only get the ones for the sine and the cosine of the sum and difference of angles. It used to be in the higher, going back a couple of decades, you would get all the trig identities, the sines, the cosines, the tangents, the sum of sines, and so on. You would get loads of them, and you had to know them. But now you don't. Why?
Well, it's hard enough for the little dears, isn't it?
Or something like that, who knows? Well, let's just derive it. You should know that sine A plus B equals sine A cos B plus, switch partners, cos A sine B. Just like in one of those Scottish dances, I don't know, Strip the Will or something, switching partners. Chris will know with his band Jiggert. And cos A plus B is cos A cos B, but minus, and then switch the partners, sine A sine B. So how does that give us tan? Well, tan is sine over cos. So if I wanted an identity for tan of A plus B, I could just divide those, which means dividing those. That doesn't look like tans, but you can create tans. It's handy once you've got a fraction, because once you've got a fraction, you can manipulate the top and the bottom to get virtually whatever you want. Well, not just quite anything you want. You can't get loads of money out of it. So if you were to divide sine by a cos, it would create a tan. So dividing by cos A, and I don't want that. So if you divide by cos A cos B, that means you'd have to divide every term on top and every term beneath to keep the fraction the same. I'll not write it out that long way because it'll form this big, huge, clumsy fraction. I'll just do it from here. Sine A divided by cos A is tan A. Cos divided by cos goes. Cos divided by cos goes. Sine B divided by cos B is tan B. Cos divided by cos goes to 1. Sine divided by cos is tan. Sine divided by cos is tan. So minus tan A tan B. You would need to know this identity to figure this problem out. Similarly, it's easy to get the other one. What's the one for the difference of the angles? Because that would just be replacing those with minus minus. In which case, if that was minus minus, that would be minus, that would be plus. So that would be tan A minus tan B over 1 plus tan A tan B. Right, so that's what you need to know for this. So let's start off. What have we got here? It's a triangle, so the angles must add up to 180. I'll just go for radians because I can't be bothered putting in the wee degree signs. So I know that x plus y plus z must add up to pi, which means x plus y is pi minus z. How can I get tangents? Easy. Pop them in. So tan of x plus y should equal the tan of pi minus z. Let's use those identities then. What is the tan of x plus y? Well, that's tan x plus tan y over 1. Remember, it was a minus tan x tan y. What's this? That's tan pi minus tan z over 1 plus tan pi tan z. So what's tan pi anyway, apart from being some place in the Far East, I presume? Well, what's the graph look like again? The tangent graph looks like this. Shoots off at pi upon 2. returns from below like a thread round a bobbin and comes back to rest there again at pi, so it's equal to 0. So that says this part here is really, that equals 0 minus tan z over 1 plus, and 0 times anything 0. So this side then is just equal to negative tan z. Let's remove the fraction then. So multiplying both sides by 1 minus tan x tan y, I'll have tan x plus tan y equals negative, you can see where this is leading, tan z minus tan x tan y. Multiply out the brackets and bring that over, and here we go, tan x plus tan y plus tan z equals, now multiplying that into here, the negative times the negative makes a positive, and it's a product of those three things. That times this is tan x, tan y, tan z. So in fact, it's an identity. Those things are always equal in a triangle, given of course, remembering that you've got this discontinuity at pi upon 2, as long as z is not equal to pi upon 2.
Of course, that's z in general, meaning any of the angles.
And if that looks a little bit unbelievable to you, you could always check that in your calculator simply by typing it in. Just picking certain angles that of course add up to 180, you can just do it in degrees in the calculator. But don't work it out and then separately work out that and try and remember if the two answers are the same. No, just divide it. If you divide by this side, it should equal 1. If you type in the tangent of something like the tangent of 30 degrees plus the tangent of, let's say, 80 degrees plus whatever's left over, that would be the tangent of 70 degrees, and divide that by tan of 30, tan of 80, tan of 70. If you type that into your calculator, you should find it gives you the answer 1, and it does. There you are.